Hello everyone. So today in the video lecture series we will be discussing from the subject circuit and network theory a important topic that is AC parallel circuit. So from this AC circuit chapter, so this is the very important portion, that is AC parallel circuit. So these are the following outlines. In this way we will discussing, that is parallel circuit, then admittance and its components, and I have taken two numerical problem, that is numerical 1 and numerical 2. Coming to next slide, introduction. So AC parallel circuit. So first of all, we all know that what is alternating current. The current which changes its magnitude and direction with respect to time, that is called alternating current. So from this alternating current, the topic that is known as AC parallel circuit, and we all aware of this series circuit, parallel circuit, and we all know that our connection in household wiring, the connection is parallel wiring, parallel circuit. So that is the what is AC parallel circuit. First point, in AC circuit in which number of branches, each branch contains number of component in series are connected in parallel, it is called AC parallel circuit. So the number of branches may be there, there may be one branch, two branch, three branch, four branch. So the branch may be connected in the components connected in series, and all the branches finally they are connected in parallel, that is known as AC parallel circuit. So the parallel circuits that is more frequently used in AC system. And what is the reason? The reason is that almost all the electrical appliances of different ratings are operated at the same supply voltage and are connected in parallel. So all the different components, appliances which are connected in our parallel connection, that maybe have different ratings, so they can operate it smoothly. Second is, each device is required to be operated independently with a switch without disturbing the operation of other devices. So if suppose one device is damaged, then other device can be operated. So this is the reason, that's why we are doing the parallel connection. So coming to the next slide. So here we can see the two impedances Z1 and Z2. These two branches are connected in parallel. Main current, supply current I is flowing, and current I1 is flowing in Z1 branch, current I2 is flowing in Z2 branch. So this Z1 and Z2 connected in parallel. So that is a parallel circuit. The figure shown, that is a parallel circuit. So from the parallel circuit, so we can see here, so that is 1 by Z equal to 1 by Z1 plus 1 by Z2, and this 1 by Z, that is known as Y, that is known as Y. What is Y? Y is called admittance. So this Y, that is known as admittance. So 1 by Z1, that is equal to Y1, 1 by Z2, that is equal to Y2. So coming to next slide, that is the admittance and its components. So you see the admittance. What is admittance? Admittance is denoted as Y. It is the reciprocal of impedance. The reciprocal of impedance, which is known as admittance, and it is denoted by the letter capital Y. So Y equal to 1 by Z. So that is the admittance. And what is the unit of admittance? The unit of admittance is mho, 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 and or the Siemens. We can write the Siemens, or in capital S can be used for the Siemens. And admittance has its two components. The components are G and B. So that's why it is written Y equal to capital G plus or minus JB. G is one component, B is one component, and the components, that is for the admittance. So admittance has two components. One is called G. G stands for conductance. Another is B. B stands for susceptance. So admittance has two components. One is conductance, another is susceptance. Y plus or minus. So coming to the next slide here. So next conductance. So conductance, what is conductance? Conductance is the reciprocal of resistance. The reciprocal of resistance is known as conductance. So we can write G equal to 1 by R. G equal to 1 by R. Then what is susceptance? The reciprocal of reactance. So we know that reactance are of two types. One is inductive reactance another is capacitive reactance, and reactance is that is represented by the letter capital X. So reciprocal of reactance is known as susceptance, and the susceptance is denoted by the letter capital B. So B equal to 1 by X. So coming to next slide. So here y equal to G plus or minus JB. So where it is plus, where it is minus. So for a series RL circuit, that is G y equal to G minus JBL. BL stands for, that is for the, because RL load is there, so inductive reactance is there, so that's why it is JBL is written. And for series RC circuit, that is G plus JBC. So BC, that is for the capacitive reactance, so that's why the susceptance is capacitive, so that is J plus JBC. So that is for the RC series circuit. So for you should remember, for RL circuit, that is y equal to J minus JBL, and for series RC circuit, that is G plus JBC. Now coming to one example, very important, this numerical problems are very important. The example we can see here in the circuit diagram, you can see the three branches are connected. In one branch resistance is connected, in the second branch the inductive reactance is connected, that is of 8 ohm, and in another third branch the capacitive reactance, that is XC, that is 20 ohm is connected, and all three branches are connected in parallel. So here in this problem, the question is asking the calculate the following: the admittance of the each parallel branch, second total admittance, and third is the impedance. So we will calculate admittance of each parallel branch. So here three parallel branch is present. So for the first branch contains resistance, second branch contains inductive reactance, third branch contains capacitive reactance. So for each branch we have to calculate the admittance, that is y1, y2, y3, then total admittance, that is y equal to y1 plus y2 plus y3, then impedance is denoted by the letter Z, so Z equal to 1 by y. So now you see, so here the first YR means the admittance for the resistance branch, so that is YR equal to, that is the value is coming, that is 0.2 S plus J0, the value that is coming, the magnitude is coming, the admittance magnitude is coming, that is 0.2 Siemens, or you can write mho also. Then YL, that is the admittance for the inductive reactance branch, so that is the value is coming, the polar value that is coming, magnitude is written 0.125 S, so this is the value 0.12 S. S stands for Siemens, or the magnitude, if anyone is asking what is the magnitude of admittance, that is 0.125 Siemens, or you can say mho also, and it is in the rectangular form, polar form, both are values are written here. And in the third branch, that is for the capacitive reactance branch, the admittance is coming, so YC, that is 0.050 S, that is the magnitude, and in the rectangular form, that is 0 plus J0, 0.050 Siemens. So this is the for individual branch, for the resistance, for the inductive reactance, for the capacitive reactance, for individual branch the admittance is calculated. So coming to the next slide. So here in the next slide, so here total admittance is calculated. So total admittance is equal to y equal to total admittance yt equal to yr plus yl plus yc. So all three values, the rectangular values are added here. So the real value added, it is coming 0.2, and the imaginary values they are added, it is coming minus 0.075, and again the value in polar form also written, that is the magnitude is written 0.2136 Siemens. Then the third, the impedance value, the impedance how it is calculated, so that is Z equal to 1 by y, Z equal to 1 by I, because we know y equal to 1 by Z. What is y? Y is called admittance, so admittance is the reciprocal of impedance. So same from this formula we can calculate Z equal to 1 by I.
Y already is calculated, total admittance. So here the admittance value already calculated. So you just do the reciprocal, you will get 4.68 ohm. So that is the impedance value that is coming. So this problem that is completed. Coming to the next slide, next example, example 2. So here again the circuit is given. So in this circuit the 4 branches are connected. You can see in the diagram, in the first branch resistance is connected, in the second branch again inductive reactance is connected, in the third branch capacitive reactance, and in the fourth branch the resistance as well as the inductive reactance both are connected in series, and finally all the 4 branches are connected in parallel. So for this 4 branch circuit, the question is asking calculate total admittance, that is Y, then total current I, then third is impedance. So Y easily we can calculate, Y equal to Y1 plus Y2 plus Y3 plus Y3, because Y4. So here 4 branches are there. So if you add the total admittance, you will get the total admittance. Then coming to total current, so that the total current can be calculated equal to I equal to V into I, then equivalent impedance. Then next slide. So here you can see for the 4 branches the Y1 value calculated, Y2 value calculated, Y3 value, Y4 value. So the Y1 that is equal to 1 by 20 plus J0, because 20 ohm resistance is only connected. So you can see in the first branch only 20 ohm is connected. So the rectangular formula can be written as 20 plus J0. Then again Y2. So in the Y2 branch you can see second branch only inductive reactance is connected. So that is J10. So that is 0 plus J10. Then Y3. So in the Y3 the capacitive reactance, that is minus J20. So that is also connected. So the final value here I have written only, and Y4 that is 1 by 5 plus J 8.66, and the final value that is coming 0.05 minus J 0.0866 S means Siemens. Then the total admittance, so for the 4 branch circuit, so that is Y equal to Y1 plus Y2 plus Y3 plus Y4. So if you add the total admittance, then you will get the value in rectangular form as well as in the polar form. The polar form, you can see the magnitude is written, that is 0.1693, and the angle minus 53.79 degree Siemens. Then the total current can be calculated I equal to V by Z or V into that is Y. So V value, magnitude voltage value that is given, so 20 angle 30 degree, and it is multiplied with the admittance, total admittance value. Then the value is coming total current magnitude 33.86 ampere, and the angle that is minus 23.79 degree. Then the total admittance, so admittance that is total impedance Z equal to 1 by Y is already calculated in the first bit. So just you do the division, then you will get the 5.91. 5.91 is the magnitude of impedance, and the angle is coming, that is minus 53.79 degree. So this is all about the AC parallel circuit. Thank you.